So this is Skills Homework 15, Calibration Calculations. Hopefully you've done lots of these in the lab. Before we go any further, these are fantastic images taken by one of our Holy Cross students. Just down a microscope with a smartphone. Even at high power, these are brilliant. So well done. His name does appear later on in this sheet somewhere. Work out the calibration value for this eyepiece scale observed at medium power. Each stage division is 0.1 millimeter. So you've done the low power, which was, so low was times 40, medium, that's usually times 100, and then later on if we do a high power one, that's going to be times 400. So hopefully you've done the low power one. And the calibration value, well, we've just remind ourselves a microscope. So a microscope is a stage with a slide on with an objective lens coming down, and there's various lenses, low power, high power, medium power and so on. Then that goes to the eyepiece. So the eyepiece is up there, and this here is our stage. And then we've got kind of a light source and a plug and so on, various knobs and twiddlers. What we can see here, so our eyepiece there is this scale here, and our eyepiece scale, it's actually written on the scale is 0 to 10, but you'll notice that there's lots of further divisions there, so we actually use this as 0 to 100. Likewise the stage which comes on a slide, and we can see, if you hold it up to the light you can actually see this, and that again has got a 0 to 10 scale on with lots of divisions on. When you measure this, my drawing's not brilliant, yeah, it's not too bad, but it's 1 centimetre long, this scale, and so it's 10 millimetres. So this whole thing is 10 millimetres long. And we use this as a 0 to 100 scale as well. So we just need to calibrate this microscope so that we can chuck the stage away and just use the eyepiece scale to actually work out the size of objects. And so, where do we start? Where do we start with this? Well, we start off with, look at what we can see really. So the eyepiece scale, we've got 100 eyepiece units. So 100 eyepiece units there equals how many of our stage units? So 1, 2, 3, 4, 5, and these are another 5, so that's 10 stage units. Each stage unit, because this is on the slide and this is like a little ruler, each stage unit, and it tells us there, is 0.1 millimeter. Each stage unit equals 0.1 millimeter. So these are all 0.1 millimeters. So now, okay. And so our 100 eyepiece units, 100 is 10 of these 0.1s, so 10 times by 0.1. And we actually want to find out what one of these eyepiece units actually measures. That'll be more useful, then we can use that in our calculations later. So we don't want 100, we want 1, so we're going to divide that by 100. So 1 eyepiece unit is whatever we had over here divided by 100. And when we do that, 10 times by 0.1 divided by 100 is 0.01 millimeters. Or if we would convert that into micrometers, another homework converting between these, that would be 10 micrometers. Or just a reminder, if I was moving this decimal place 3 places that way, then that would give us our 10 micrometers. Either of those answers there is absolutely fine for our calibration value. Question 2. Same thing again, but this time we're under high power. So an excellent image here showing the stage and the eyepiece scale there. These are still the same. It's the same thing, but just more magnified. So these are still 0.1 millimeters there. And our eyepiece scale is still the same. We're going to use that 0 to 100 there. And again, we're looking for something that we can say what we see. So if we say take this point here, between these two, we have got 40 of our small eyepiece scale units, and that equals to one of our stage units, or 0.1 millimeters. So that's what we're gonna use. So we've got 40 eyepiece units is one stage division. One stage division. And a reminder that each stage division is 0.1 millimeter. I know you can cut some of these steps out, but then you're very prone to mistakes. So we're going to write it out in full here. And so 40 eyepiece units is one stage division times by our 0.1 millimeter, which would equal just 0.1 millimeter. We don't want 40 of them. We just want to find out what one of these small divisions is going to be, and then when we look at bacteria or algae or anything else interesting, we can just measure it and times it up. So we don't want 40, we want 1, so we divided that by 40. Is all of this over here divided by our 40 there. So we go 1 times by 0.1 divided by 40 is this number here, 0.0025. What units are we in? Well, we're still in millimeters. We haven't changed from millimeters yet. And we could put that into another more sensible unit. We could put that into micrometers. So convert that and need to times it by 1,000, or I can just do that by moving my decimal place 3 points over. And so that's going to be 2.5 micrometers there. So at our high power, our calibration value for one eyepiece unit is 0.0025 millimeters or 2.5 micrometers. What have we got now? So question 3. So this is a diagram rather than one of our fine micrographs produced by a student. What have we got here? Right, a little trick here. This is a different stage micrometer, a different one. So we've got 1 millimeter there. So this whole thing is 1 millimeter. And we're dividing that into 100. So each stage unit is not what we were using before. It's actually 1 divided by 100th. So each stage division is 1 millimeter divided by 100. So that is equal to 0.01 millimeters. So a slight change to what we had before. And now we can just do the same thing, say what you see. So probably the easiest way to do it is to look at this entire scale from 0 to 100 there is the same as, those are nicely lined up to, not quite 80, probably 82 there. So 100 of our stage divisions is 82 of our eyepiece, and we just need to write that out. So same as before, 82 eyepiece units is 100 stage divisions. Let's remind ourselves again, each stage division, I have extreme problems writing some words, is 0.01 millimeters, and so 82 eyepiece units is 100 of our 0.01s, and that would still be in millimeters. We don't want 82 of them, that's a strange thing to be trying to calculate later. We want one of them, that'll make it nice and easy. So one eyepiece unit, so we divided that by 82, so we're going to have to do the same to the other side. 100 times by 0.01 divided by 82, and when we put that into our key, you can't do that one in your head. 100 times by 0.01 divided by 82 is that fine number there, 0.0121, 1951, etc. So that would be still in millimeters. We could round that off, or possibly we could convert that into a more sensible unit like micrometers. So again, times it by 1,000 to get micrometers. 1, 2, 3. So we'd get 12.1951. Okay, well we'll have 12.2 there, possibly a bit the most sensible way of doing that, because we were using kind of 3 significant figures here with 100. That is micrometers. Okay, so we're going to have to round off, put our millimeters to 3 significant figures, or we could convert into micrometers there. Question 4. I might be able to just fit this on this sheet nicely. A pine needle. TS transverse section, so a slice through it at medium power. So medium power was our calibration here. This was medium power, which was our times 100. Use the eyepiece scale and your answer to question 1 to calculate the actual width. So this is actually when we're actually deciding how big things are. The number 0 on the eyepiece scale is the top edge of the pine needle. So that's our 0 there, and we need to just, if I make these just a little bit clearer on there, it's not there, 5, 4, and then, okay, so we've got 0 there, and that one there, so 1, 2, 3, 4, and so on. But remember that we're using the little divisions, so we're going to look at it like that. And so where's the edge of our pine needle? So there. And so I think we should have 57 for that. So it's 57 eyepiece units. So let's just remind ourselves. So 1 eyepiece unit, our calibration value, at our medium power was 10 micrometers there. Okay, so I'm going with the micrometers rather than the millimeters. What else do we know? How many eyepiece units have we actually got? Notice the stage isn't there anymore because we took the stage off and put this pine needle slide on, so we can't see the stage, but we don't need to because we calibrated it. So let's say what we've got. Width of pine needle is 57 eyepiece units. Okay, and each eyepiece unit is 10 micrometers, so the width of the pine needle is 57 of these 10 micrometers, so 57 times 10, and you should be able to do that in your head, 570 micrometers. And does that pass the sensible test? Well, if you've got a pine needle, is it about 500 micrometers or half a millimeter? And that sounds about right, so we'll go with that. And that's the end of that skills on calibration.